In this video, we're starting section 5.4 on log properties. Log properties. So our goals are, we're going to evaluate log expressions using log properties, and then recognize when using log properties might change the domain of a function. And then we'll talk about how can we solve exponential equations when we need logs. So these are situations where they won't have a nice answer that I could just get by getting a common base. Okay. All right, so let's recall that if I have an exponential function, a to the x, and as long as that base is greater than 0 and it's not equal to 1, well, the inverse is log base a of x. So the inverse of our exponential function is a log function. And we've seen before that if you plug in an inverse into the original function f of x, well, you just get x. And same thing if you do it the other way around. If you plug in f of x into the inverse, you also get x. So one of the ways that I think about this is if you plug in an inverse into the original, well, these two, they kind of cancel each other, and you'll be left with whatever's inside, the x. And same thing with this one. They kind of cancel, and you're left with whatever's inside, the x. Okay, so if we do this with our functions here, so if I do this first one, f is a to the x, but instead of plugging in just x, this is what's inside. I got to plug in f inverse of x, which is my log, in where the x used to be. So I'll get a to the log base a of x. A to the log base a of x, that's what I get on the left-hand side. So this whole thing becomes, whoops, sorry, I didn't write log base a, I wrote log base 2. Let me fix that. This should be log base a of x. Whoops, let me go to highlight mode. And this equals, what I got on the right side is x. So the way I kind of think about this, remember this, my trick for it is if I have a base here, the base of my exponent, and that matches the base of the log that I have in the power, they kind of undo each other because they're inverses. And I'm just left with whatever's inside the log, which is x. Okay, so what does this look like in the other order, in this order? Well, I'll have f inverse on the outside, which is log base a, but now I'm not plugging in x, I'm going to plug in what f of x is. And f of x is a to the x, and in this order as well, I should just end up equaling x. And again, if the base of the log matches the base of the power that's inside the log, they kind of cancel because they're inverse functions, and I'll be left with just the exponent, which is x. Okay, so in this order, this f inverse of f of x became this. All right, so let's do some examples where we use these. So part A says, let's evaluate 2 to the log base 2 of 16. Okay, so first, I'm going to do this in two ways. So let's first figure out what the exponent is, log base 2 of 16, because that's one we can work out. This would be asking ourselves, 2 to what power equals 16? Oh, but that power is 4. Oh, so that's what log base 2 of 16 is. And now let's write that in our expression. So we want to know 2 to the log base 2 of 16. And now I know this exponent is 4. Log base 2 of 16 is 4. That's what we just figured out. And then 2 to the 4, that's just 16. So that's my answer. Okay, we can also do this using one of our two properties up here. Because my problem looks like property 1. I have 2 to the log base 2 of 16. So property 1 says, well, when I got this base of my exponent, if that matches the base of the log that is in the power, they kind of cancel, and we're left with whatever's inside the log, which is just 16. Okay, and that's my answer. So this is by that first property. All right, let's do another example. Part B, so what if I did the same thing with a 20 inside? So this time I couldn't do method 1, because if I did method 1, I would need to know 2 to what power equals 20, and then I'd get stuck because 20 is not a perfect power of 2 like 16 was. But I can use my method 2. So in method 2, because the base of this power and the base of that log, they're the same, they cancel, and I'll end up with a 20. And that's my answer. Okay, nice. Okay, let's do the next one. What is log base 2 of 1024? So this looks more like my second property. I have the log on the outside, and I'll have to think about, can I make the inside be a power? So I got log base 2, and the inside is 2 to the 10. 2 to the 10 is 1024. So that second property says, well, if you got a log on the outside, if the base of the log matches the base of the power on the inside, they kind of cancel, and you're left with just the exponent, which is 10. And that is our answer. So this isn't the only way I could have done it. I could have also just done this by transforming it. We'd be asking ourselves 2 to what power equals 1024? And the answer to that is, well, the power is 10. And that's the answer we got here. Okay, let's do one more of these. What is log base 2 of 2 to the 1234? So again, I'm going to use that second property. Because the base of the log matches the base of the power inside the log, they kind of undo each other. They cancel each other because they're inverse functions. And we'll just be left with the exponent, the 1234. And that is our answer.